Imagine a world where high-speed internet is no longer a luxury, but a universal right, accessible from the most remote corners of the planet. Picture a farmer in the middle of a vast, untouched field, a researcher in the Arctic, or a family in a rural village, all connected to the global web of information, communication, and opportunity. This is not a distant dream. It's a reality being built today, one satellite at a time. The science behind Starlink satellites is not just about technology. It's about bridging divides, empowering communities, and redefining what's possible. At the heart of this revolution lies a constellation of satellites orbiting Earth, each one a marvel of engineering and innovation. These satellites, part of the Starlink project, are designed to deliver high-speed internet to every corner of the globe, even in places where traditional infrastructure has failed to reach. But how do these satellites work? What makes them so special? And what does it take to build them? The journey begins with the satellites themselves. Each Starlink satellite is a compact, table-sized marvel weighing around 260 kilograms. Despite their small size, they are packed with cutting-edge technology designed to withstand the harsh conditions of space while delivering unparalleled performance. The satellites are equipped with advanced phased array antennas, powerful ion thrusters, and sophisticated communication systems, all working in harmony to beam internet signals to and from Earth. One of the most remarkable aspects of Starlink satellites is their ability to communicate with each other. Unlike traditional satellites that rely on ground stations to relay data, Starlink satellites use laser links to transmit information directly between themselves. This creates a vast, interconnected network in space, enabling data to travel at the speed of light across the globe. Imagine a web of light stretching across the heavens, connecting continents and oceans in an instant. This is the vision behind Starlink's laser communication system. But building these satellites is no small feat. Each one is a masterpiece of precision engineering, requiring thousands of components to be meticulously assembled and tested. The process begins with the design phase, where engineers use advanced computer simulations to model every aspect of the satellite's performance. From the shape of its solar panels to the configuration of its antennas, every detail is optimized to ensure maximum efficiency and reliability. Once the design is finalized, the manufacturing process begins. The satellites are built in state-of-the-art facilities, where robotic arms and automated systems work alongside skilled technicians to assemble the intricate components. The phased array antennas, for example, are made up of hundreds of tiny elements, each one carefully calibrated to transmit and receive signals with pinpoint accuracy. The solar panels, which provide power to the satellite, are made from ultra-lightweight materials designed to withstand the extreme temperatures and radiation of space. After assembly, each satellite undergoes rigorous testing to ensure it can survive the journey to orbit and perform its mission flawlessly. This includes vibration tests to simulate the intense forces of launch, thermal tests to replicate the extreme temperatures of space, and vacuum tests to ensure the satellite can operate in the absence of air. Only after passing these tests is the satellite deemed ready for launch. The launch itself is a spectacle of engineering and coordination. The satellites are packed into the payload fairing of a rocket, carefully stacked to maximize space and minimize weight. As the rocket ascends through the atmosphere, the satellites are released into orbit, one by one. like seeds being scattered across the sky. Once in orbit, the satellites use their onboard propulsion systems to maneuver into their final positions, forming a constellation that spans the globe. But the science behind Starlink doesn't stop at the satellites. On the ground, users connect to the network using a compact, user-friendly terminal, often referred to as Dishy McFlatface. This terminal, which looks like a small, futuristic dish, is equipped with its own phased array antenna, allowing it to communicate with the satellites overhead. The terminal automatically aligns itself with the nearest satellite, tracking its movement across the sky and maintaining a steady connection. The magic of Starlink lies in its ability to seamlessly switch between satellites as they pass overhead. Each satellite is in constant motion, orbiting the Earth at speeds of over 27,000 kilometers per hour. As one satellite moves out of range, the terminal instantly connects to the next one, ensuring a continuous, uninterrupted internet connection. This dynamic, ever-changing network is what makes Starlink so powerful, enabling it to deliver high-speed internet to even the most remote locations. The impact of Starlink is already being felt around the world. In rural communities, it's providing access to education, healthcare, and economic opportunities that were previously out of reach. In disaster-stricken areas, it's restoring communication when traditional infrastructure has been destroyed. And in developing countries, it's bridging the digital divide, empowering people with the tools they need to thrive in the 21st century. But the story of Starlink is about more than just technology. It's about the human spirit of exploration and innovation. It's about pushing the boundaries of what's possible and using science to solve some of the world's most pressing challenges. It's about creating a future where everyone, no matter where they are, has the opportunity to connect, learn, and grow. As we look to the stars, we are reminded of the incredible potential of human ingenuity. The science behind Starlink satellites is a testament to what we can achieve when we dream big and work together. It's a reminder that the sky is not the limit. It's just the beginning. The story of Starlink is not just about the satellites themselves, but also about the countless hours of research, innovation, and collaboration that go into making this vision a reality. Behind every satellite, every ground terminal, and every byte of data transmitted lies a team of engineers, scientists, and dreamers who are pushing the boundaries of what's possible. It's a story of perseverance, of solving problems that once seemed insurmountable, and of creating a future where connectivity is as universal as the air we breathe. One of the most fascinating aspects of Starlink is the sheer scale of the project. To provide global coverage, the constellation will eventually consist of tens of thousands of satellites, all working in harmony to create a seamless network. This is no small task. Each satellite must be precisely positioned in its orbit, carefully spaced to avoid collisions and ensure optimal coverage. The coordination required to manage such a vast network is mind-boggling, relying on advanced algorithms and real-time data to keep everything running smoothly. But the challenges don't end there. Space is an unforgiving environment filled with hazards that can threaten the lifespan and functionality of satellites. Micrometeoroids, radiation, and extreme temperature fluctuations are just a few of the obstacles that must be overcome. To address these challenges, Starlink satellites are built with durability in mind. They are equipped with radiation-hardened electronics thermal control systems, and redundant components to ensure they can withstand the rigors of space. Even with these precautions, the satellites are not designed to last forever. Over time, their orbits will decay, and they will need to be replaced. This is where the concept of sustainability comes into play. Unlike traditional satellites, which often become space debris at the end of their lives, Starlink satellites are designed to deorbit and burn up in the Earth's atmosphere once their mission is complete. This approach helps to minimize space debris and ensure that the orbits remain clear for future generations of satellites. The science behind Starlink also extends to the ground, where the user terminals play a crucial role in connecting people to the network. These terminals, often referred to as dishy McFlatface, are a marvel of engineering in their own right. Despite their compact size, they are capable of tracking satellites moving at incredible speeds, adjusting their position in real time to maintain a stable connection. This is made possible by the phased array antenna technology, which allows the terminal to steer its beam electronically without any moving parts. The terminals are designed to be user-friendly, requiring minimal setup and maintenance. Simply plug it in, point it at the sky, and it will automatically connect to the nearest satellite. This ease of use is a key factor in making Starlink accessible to people who may not have technical expertise, ensuring that anyone, anywhere, can benefit from the network. But the impact of Starlink goes beyond just providing internet access. It's about empowering people with the tools they need to thrive in a connected world. For students in remote areas, it means access to online education and resources that were previously out of reach. For small businesses, it means the ability to reach global markets and compete on a level playing field. For communities, it means staying connected during emergencies and disasters, when traditional communication networks may be down. The potential applications of Starlink are virtually limitless. From enabling telemedicine in underserved areas to supporting scientific research in the most remote corners of the planet. The network is opening up new possibilities for how we live, work, and interact with the world. It's a testament to the power of innovation and the belief that technology can be a force for good. As we look to the future, the story of Starlink is far from over. The constellation is still growing, with new satellites being launched on a regular basis. Each launch brings us one step closer to the goal of global connectivity, one step closer to a world where no one is left behind. But the journey is not without its challenges. As the constellation grows, so too does the need for careful management to avoid overcrowding in orbit and ensure the long-term sustainability of space. There are also questions about how to balance the benefits of global connectivity with concerns about privacy, security, and the environmental impact of launching thousands of satellites into space. These are complex issues that will require collaboration and innovation to address. But if the story of Starlink has shown us anything, it's that no challenge is too great when we work together and dare to dream big. In the end, the science behind Starlink is about more than just satellites and technology. It's about the human spirit of exploration and the belief that we can create a better future for everyone. It's about breaking down barriers, connecting people, and unlocking the potential of the digital age. This is the story of Starlink, a story of hope, progress, and the endless possibilities of human ingenuity. And it's a story that is still being written, one satellite one connection, and one life at a time. The story of Starlink is not just a tale of technological achievement, it's a narrative about humanity's relentless pursuit of progress and the profound impact that connectivity can have on our lives. It's about breaking down the barriers that separate us, whether they are geographical, economic, or social, and creating a world where everyone has the opportunity to thrive. As we delve deeper into the science and vision behind Starlink, we uncover layers of innovation, challenges, and hope that paint a vivid picture of what the future could hold. One of the most awe-inspiring aspects of Starlink is its ability to bring the internet to places that have never had it before. Imagine a small village nestled in the mountains, far removed from the bustling cities and modern infrastructure. For generations, the people there have lived without access to the vast resources of the internet. No online education, no telemedicine, no ability to connect with the wider world. But with the arrival of a Starlink terminal, everything changes. Suddenly, a child in that village can attend virtual classes. A farmer can access real-time weather data to optimize crops, and a family can video call relatives living thousands of miles away. This is the transformative power of connectivity, and it's at the core of what Starlink aims to achieve. But how does this magic happen? How does a satellite, orbiting 550 kilometers above the Earth, deliver internet to a remote village or a ship in the middle of the ocean? The answer lies in the intricate dance between the satellites, the ground terminals, and the advanced algorithms that orchestrate their movements. Each Starlink satellite is equipped with multiple high-performance antennas that can transmit and receive data at incredible speeds. These antennas use a technology called phased array beamforming, which allows them to focus their signals into tight, precise beams. This is crucial because the satellites are moving at speeds of over 27,000 kilometers per hour, and the ground terminals are stationary. To maintain a stable connection, the satellite must continuously adjust its beam to track the terminal as it moves across the sky. This is where the ground terminal, affectionately known as Dishy McFlatface, comes into play. The terminal is not just a passive receiver, it's an active participant in the communication process. Using its own phased array antenna, the terminal can steer its beam to lock onto the satellite, ensuring a strong and stable connection. This dynamic interplay between the satellite and the terminal is what makes Starlink so effective, even in the most challenging environments. But the science behind Starlink doesn't stop at the hardware. The software that powers the network is equally impressive. Every satellite in the constellation is part of a vast, interconnected system that relies on real-time data and advanced algorithms to optimize performance. For example, the network uses machine learning to predict the movement of satellites and adjust their trajectories to avoid collisions. It also uses sophisticated routing algorithms to ensure the data takes the most efficient path from the user to the internet, backbone, and back, deorbited and repositioned to maintain optimal coverage. As new satellites join the network, they must be seamlessly integrated into the existing system, ensuring that users experience no disruption in service. This requires a level of precision and reliability that is unprecedented in the history of satellite technology. Another groundbreaking aspect of Starlink is its use of laser communication between satellites. Traditional satellite networks rely on ground stations to relay data, which can introduce delays and limit coverage. Starlink, on the other hand, uses laser links to transmit data directly between satellites, creating a high-speed backbone in space. This not only reduces latency, but also extends the network's reach. This level of coordination is essential because the Starlink constellation is not static. Satellites are constantly being launched to areas where ground stations are impractical, such as the middle of the ocean or the polar regions. The implications of this technology are profound. For example, consider a research team stationed in Antarctica. In the past, their ability to communicate with the outside world was severely limited, relying on slow and unreliable connections. But with Starlink, they can now access high-speed internet, enabling real-time collaboration with colleagues around the globe, streaming live data from their experiments, and even participating in virtual conferences. This is just one example of how Starlink is breaking down barriers and enabling new possibilities. But the impact of Starlink goes beyond individual users. The network has the potential to revolutionize entire industries, from agriculture to transportation to disaster response. For example, farmers can use Starlink to access real-time data on soil conditions, weather patterns, and crop health, allowing them to make more informed decisions and increase yields. Similarly, shipping companies can use the network to track their vessels in real time, optimize routes, and improve safety. In disaster-stricken areas, Starlink can play a critical role in restoring communication and coordinating relief efforts. When traditional infrastructure is damaged or destroyed, the network can provide a lifeline for first responders, enabling them to communicate, share information, and save lives. This was demonstrated during the aftermath of Hurricane Ian in 2022, when Starlink terminals were deployed to provide emergency connectivity in affected areas. As we look to the future, the potential of Starlink is virtually limitless. The network is still in its early stages, with plans to expand the constellation to tens of thousands of satellites. This will not only improve coverage and performance, but also open up new possibilities for innovation. For example, the network could be used to support the development of autonomous vehicles, enabling them to communicate with each other and with infrastructure in real time. It could also be used to support the growing demand for Internet of Things IoT devices, creating a truly connected world. But with great power comes great responsibility. As the Starlink constellation grows, so too does the need to address concerns about space debris, light pollution, and the environmental impact of launching thousands of satellites into orbit. These are complex issues that will require collaboration between governments, industry, and the scientific community to solve. Despite these challenges, the story of Starlink is one of hope and possibility. It's a reminder that when we combine science, innovation, and a shared vision for a better future, we can achieve incredible things. It's a testament to the power of technology to transform lives and bring people together. So the next time you look up at the night sky, take a moment to think about the invisible network of satellites orbiting above, silently working to connect the world. Each one is a symbol of what we can achieve when we dare to dream big and work together to make those dreams a reality. This is the story of Starlink, a story of innovation, connection, and the endless possibilities of human ingenuity. And it's a story that is still being written. One satellite, one connection, and one life at a time. As we continue to explore the science behind Starlink, we are reminded that the journey is just as important as the destination. It's about the challenges we overcome, the lessons we learn, and the lives we touch along the way. It's about creating a future where everyone, no matter where they are, has the opportunity to connect, learn, and grow. This is the promise of Starlink, a promise that is being fulfilled every day, one beam of light at a time.